When installing a subpanel in a detached garage fed from a house with a 200 amp single-phase 3-wire service, the ground wire, also known as the equipment grounding conductor, must be run with the circuit conductors from the main panel in the house to the subpanel in the garage. A ground electrode system installed at the garage, such as ground rods or a ground ring, cannot be used to eliminate the need for the equipment grounding conductor run with the feeder conductors. The purpose of the equipment grounding conductor is to provide a lower impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices like circuit breakers or fuses, thereby minimizing the risk of electrical shock or fire. The National Electrical Code, or NEC, specifically addresses the requirements for grounding and bonding in detached structures. It mandates that an equipment grounding conductor must be run with the feeder conductors to ensure a reliable ground fault current path. This is particularly important when the feeder is run underground, as is the case with conductors buried in PVC conduit. The NEC outlines these requirements in Article 250, which covers grounding and bonding. Specifically, Section 250.32 addresses grounding requirements for separate buildings or structures. It clarifies that the equipment grounding conductor must be run with the supply conductors. The exception to this rule, which allows for the grounding electrode conductor at a separate building to be connected to a grounding electrode, does not eliminate the requirement for the equipment grounding conductor to be run with the feeder. The grounding electrode at the garage serves a different purpose, which is to stabilize the ground potential and provide a path for lightning and other transient voltages to ground. However, it cannot handle the high fault currents that may occur during an electrical fault. To properly install the subpanel, the following steps and considerations are crucial. Firstly, run 4 conductors from the main panel in the house to the subpanel in the garage. These conductors include 2 ungrounded conductors, often referred to as hot wires, a neutral conductor, and an equipment grounding conductor. Secondly, ensure that the size of the conductors is appropriate for the ampacity of the subpanel and the overcurrent protection device in the main panel. Consult NEC Table 310.16 for ampacity ratings of conductors based on their insulation type and temperature rating. Thirdly, the equipment grounding conductor must be sized according to NEC Table 250.122, based on the rating of the overcurrent protective device protecting the feeder conductors. Fourthly, at the subpanel in the garage, the neutral conductor must be isolated from the enclosure. This means that the neutral conductor should be connected to a neutral bus bar that is not bonded to the subpanel enclosure. Fifthly, the equipment grounding conductor must be connected to a separate grounding bus bar that is bonded to the subpanel enclosure. Sixthly, install a grounding electrode system at the garage. This typically involves driving 1 or more ground rods into the earth. The grounding electrode conductor, which is typically a copper wire, connects the grounding bus bar and the subpanel to the ground rod. Seventhly, the size of the grounding electrode conductor must be in accordance with NEC Table 250.66, based on the size of the service entrance conductors or the equivalent size of the feeder conductors. Eighthly, all metal components of the electrical system, including the subpanel enclosure, metal conduit, and metal boxes, must be bonded together to form a continuous electrical path to ground. This bonding ensures that all metal parts are at the same electrical potential, which minimizes the risk of electrical shock. Ninthly, use appropriate fittings and connectors for all electrical connections. Ensure that all connections are tight and secure to prevent loose connections, which can cause overheating and electrical hazards. Tenthly, properly label all circuits and components in the subpanel to facilitate future maintenance and troubleshooting. This includes labeling the circuit breakers, conductors, and grounding connections. In summary, the equipment grounding conductor is essential for providing a safe and reliable electrical system in a detached garage. It cannot be eliminated by installing a grounding electrode system at the garage. The grounding electrode system serves a different purpose and does not provide the necessary low impedance path for fault current to return to the source. Adhering to the NEC requirements for grounding and bonding is crucial for ensuring the safety of people and property. The importance of the equipment grounding conductor in a subpanel installation cannot be overstated. It plays a vital role in protecting against electrical shock and fire hazards. When an electrical fault occurs, such as a short circuit between a hot wire and a metal enclosure, the equipment grounding conductor provides a low impedance path for the fault current to flow back to the source, which is the main panel in the house. This high fault current causes the overcurrent protective device, such as a circuit breaker or fuse, to trip or blow, which quickly interrupts the flow of electricity and prevents the metal enclosure from becoming energized. Without the equipment grounding conductor, the metal enclosure could become energized, posing a significant risk of electrical shock to anyone who comes into contact with it. The grounding electrode system at the garage, while important for other reasons, cannot perform this function. The grounding electrode system, which typically consists of ground rods or a ground ring, is primarily intended to stabilize the ground potential and provide a path for lightning and other transient voltages to dissipate into the earth. It is not designed to handle the high fault currents that may occur during an electrical fault. The impedance of the grounding electrode system is typically much higher than that of the equipment grounding conductor, which means that it would not provide a sufficiently low impedance path for fault current to return to the source and trip the overcurrent protective device. The NEC clearly requires that the equipment grounding conductor be run with the feeder conductors to the subpanel in the garage. This requirement is based on decades of experience and research that have demonstrated the importance of a reliable ground fault current path for electrical safety. Ignoring this requirement can have serious consequences, including electrical shock, fire, and property damage. In addition to the equipment grounding conductor, proper bonding of all metal components of the electrical system is also essential for electrical safety. Bonding refers to the practice of connecting all metal parts of the electrical system together to form a continuous electrical path to ground. This includes the subpanel enclosure, metal conduit, metal boxes, and any other metal components that may become energized during an electrical fault. Bonding ensures that all metal parts are at the same electrical potential, which minimizes the risk of electrical shock. If one metal part becomes energized, the fault current will flow through the bonding conductors to all other metal parts, causing the overcurrent protective device to trip and to energize the entire system. Without proper bonding, different metal parts could be at different electrical potentials, creating a shock hazard for anyone who comes into contact with them. The NEC provides specific requirements for bonding in Article 250. These requirements specify the size and type of bonding conductors that must be used, as well as the methods for connecting them to the metal components. It is important to follow these requirements carefully to ensure that the electrical system is properly bonded and that the risk of electrical shock is minimized. In conclusion, when installing a subpanel in a detached garage, it is essential to run the equipment grounding conductor with the feeder conductors from the main panel in the house to the subpanel in the garage. A grounding electrode system at the garage cannot replace the equipment grounding conductor. Proper bonding of all metal components of the electrical system is also essential for electrical safety. Adhering to the NEC requirements for grounding and bonding is crucial for ensuring the safety of people and property. Consulting with a qualified electrician is highly recommended to ensure that the subpanel is installed correctly and safely. The electrician can assess the specific conditions of the installation and provide guidance on the appropriate grounding and bonding methods to use. Additionally, they can perform inspections and testing to verify that the electrical system meets all applicable codes and standards. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals if you are not comfortable or qualified to do it yourself. By following these guidelines and working with a qualified electrician, you can ensure that your subpanel installation is safe, reliable, and compliant with all applicable codes and standards. This will provide peace of mind and protect your family and property from electrical hazard.